The current climate change and global warming our world is facing today is majorly due to the emissions of greenhouse gases. Globally, the building sector consumes approximately 40% of energy and contributes 33% of carbon emissions. In Ghana, the need for thermal performance places a huge demand on energy, which leads to a rise in both embodied and operational carbons, especially with the rise in urbanization and population growth. To mitigate this, passive design strategies have been explored and implemented. However, there is one notable approach that has not been used much, and that is the use of green roofs. Hi, my name is Sharon Agyeman with my colleagues Felix Dwamena-Yamoah and Clement Thompson, construction students of KNUST, class of 2024.
Green roofs are cultivated plants on rooftops, an innovative way to incorporate nature into the urban environment. Green roofs have several benefits, including improving air quality, reducing urban heat island, and for buildings, they have the potential for leveling up indoor thermal conditions and reducing energy consumption for cooling. Our research was motivated by the need to assess the environmental impact of green roofs in Ghana. We explored the potential of green roofs in improving building indoor conditions, reducing energy consumption and carbon emissions, focusing on embodied carbon and operational carbon. By integrating building information modeling with life cycle assessment, we conducted a comprehensive analysis of the environmental benefits of green roofs.
Our study was a comparative study. An existing experimental test cell with concrete roof was modeled after an on-site measurement using Rhino Grasshopper 3D. Energy simulations were run with Energy Plus using Ladybug and Honeybee plugins, which helped us in validating the model. Validation was achieved by comparing both the simulated results from the base model to pre-recorded air temperature and mean radiant temperature of the test cell. The model's operational carbon emissions, embodied carbon emissions, and thermal performance were assessed. Finally, the model was modified to include green roof components. We reran the simulations and compared the results to the base model.
We discovered that the green roof model was able to save up to 14% of energy and was 2.7 times more comfortable in terms of thermal performance as compared to the test cell, which was made up of the concrete roof. However, the choice of materials and construction processes has a critical role it plays by impacting its environmental performance.
So what does this mean for the future of sustainable building in Ghana? The findings of our study advocate for the adoption of green roofs as a sustainable alternative to conventional roofing systems. By reducing embodied and operational carbon, lowering energy consumption, and improving indoor thermal conditions, green roofs offer multiple environmental and economic benefits. These advantages not only support the global movement for more sustainable building practices, but also provide tangible improvements in building performance and occupant well-being. Hence, integrating green roofs into building design should be considered as a valuable strategy in enhancing sustainability and energy efficiency in the built environment. But there is more work to be done. Future research should explore different types of green roofs and various climatic conditions, and also the long-term performance of green roofs, including maintenance challenges.